This is the second video on section 4.9, the normal and binormal vectors. And so here we're going to look at example 113. I have worked the parts out in a slightly different order than what's in the notes. And so I've done part C before part B. In part A, we want to find the unit tangent vector. So we start by calculating the derivative of r. The magnitude of r prime is 3. And so the unit tangent vector is 1 divided by 3 is our scalar, multiplied with r prime. And so the unit tangent vector should be a unit vector. And then to find the unit normal vector, we calculate t prime. And the unit normal vector, by definition, is t prime divided by magnitude of t prime. For this particular example, the magnitude of t prime happens to be 1. This doesn't always happen. That's why the unit normal vector is defined the way that it is. We divide by the magnitude of t prime. Generally, that's not equal to 1, but for this example it is. So in this case, the unit normal vector is simply t prime. The curvature is the magnitude of t prime divided by the magnitude of r prime, which is 1/3. And then finally for part D, we want to calculate the binormal vector, which is t cross n. And so we set up the determinant, and for the first entry, we ignore i's row, ignore the column, and we have 0 minus 0, which is 0. For the second entry, we ignore j's row, ignore the column. We have negative cosine squared minus sine squared. That is -1. But because it's the second component, we change the sign. So we have a +1. And finally, for the third component, ignore k's row, ignore k's column. Again, we have 0, 0, minus 0. And so our third component is 0.